Hello and welcome to lesson 5.4. So once again, this chapter is all about doing operations with polynomials. We've added, subtracted, multiplied. Now we're going to divide polynomials. We'll only focus on dividing by single term polynomials, or what are known as monomials. If you want to divide by more than one term, you're going to need something called long division or synthetic division. For today's lesson, though, we need to recall all of our exponent rules to be able to pull this off. So I think we're kind of ready to jump into some examples and start talking about this. So let me give you the first example. 6x to the fourth plus 8x squared minus 12x. And we would like to divide that by, so that's a three-term polynomial, a trinomial. We would like to divide that by 2x. Okay? This is a single-term polynomial that we're dividing by. So how this works is this is kind of like distributing. When I have a whole bunch happening up here with plus signs and minus signs, and I have a single term. Now this only works if there's a single term down here. If you have any pluses or minuses down here, I cannot do this in the same manner. But with a single term down here, I can divide each term. So I'm going to take the time to write this out, but usually I will not write this out. Each term kind of gets a distributed, this divided by 2x. Like I said, most people would not write this out. I will not write it out after this example, but every term on the top gets divided by this term on the bottom. And so then I can go about using my exponent rules and just simplifying. For instance, I know 6 divided by 2 is 3. And then exponent rules, x to the fourth divided by x. Let's do some exponent rule scratch work. X to the fourth divided by x. I need an exponent on this plain x, so that's a 1. And the rule tells me to take the top exponent minus the bottom exponent, so that'd be x to the third. Okay, so 6 divided by 2 is 3. X to the fourth divided by x is x to the third. All right, next term. 8 divided by 2 is 4. X squared divided by x, if you use your exponent rules, is x. Bring down your sign there. 12 divided by 2 is 6. And x divided by x, that's x to the, if I had to use exponent rules, x1 over x1, which is x to the 0th power, which is 1. So 6 times 1, but I don't need to show the 1. Or you could think of it as the x's cancel. Okay, that was not really that difficult. Actually dividing by a single polynomial, a single term polynomial known as a monomial, may be one of the easiest things we've done in this chapter so far. And that's saying a lot considering we just added and subtracted polynomials a few lessons ago. Let's do a few more examples before we say it's the easiest thing we've done. So let's go with 15x to the 10th minus 21x to the 8th plus 9x to the 6th. And let's divide this by 3x to the 5th. All right. I'm not going to take the time to write it out as 3 separate terms this time, but we have the idea. We know that every term on the top will be divided by this. So 15 divided by 3 is 5, and x to the 10th divided by x to the 5th, if you needed to take the time to do the exponent rules, x to the 10th over x to the 5th, those would subtract and give you 10 minus 5 is 5, so x to the 5th. All right, I'm going to stop doing my scratch work and do it in my head for the rest of the lesson. I think you should be able to join. If there's one you're curious about, pause it and do the scratch work out to the side. So negative 21x to the 8th divided by 3x to the 5th. Well, negative 21 divided by 3 is negative 7, and x to the 8th divided by x to the 5 is x to the 3rd, plus 9x to the 6th divided by 3x to the 5th. That would be 3x, because 9 divided by 3 is 3, and x to the 6th divided by x to the 5th is x. So wow, that is really simple. One more example, and then we'll step into something similar, but slightly different. What if I were to give you an example like this? 12x squared plus 18x minus 24. And let's divide this by 6x. Well, I would just still do this the same way. 12 divided by 6 is 2. X squared divided by x is x. Next term is a positive term. 18x divided by 6x. 18 divided by 6 is 3. And x divided by x reduces. Then I have negative 24 divided by 6x. That would give me negative 4x to the negative 1. If you don't believe me, we could do the scratch work here. Well, negative 24 divided by 6 is definitely negative 4. And if I try to bring this all up into a single term, there's nothing here. This is x to the 0 divided by x to the 1, which would be x to the negative 1. I don't want to leave it as negative, so I better leave that x on the bottom. So this is more correct or more proper. Okay, so that's the weirdest thing, the only weird thing. And that's only because we have more x on the bottom than one of these other terms. If I go back and look, I've had a smaller exponent on the bottom. But if this was like 7, I would end up with the same thing here, where I would have an x on the bottom in this final answer. Okay? Well, if you feel confident on that, that's as hard as we're going to make that. Let's kind of use these skills to start our beginning of our factoring journey. So we were going to kind of, this is, instead of teaching you long division in this course, we're going to dive into a more useful skill of factoring, but we're going to start with the baby steps of factoring, okay? So what is factoring? Well, division is to undo multiplications. Factoring also is to undo multiplications. It's kind of like, it's like if you could go back in time and pull apart multiplications. Okay, so if someone multiplied something and gave you the polynomial and you say, I want to know what it was originally, I would like to pull apart the multiplications to be able to look at what things were multiplied to give us that. So we're going to start with something that's kind of related to the division. We're going to start by trying to factor out, and this should be our starting point every time we go to factor, the GCF. This stands for the greatest common factor. Okay? Now, what in the world is the greatest common factor? Let's talk about it with an example. Let's say I have 10x plus 15. And I would like to be able to kind of undistribute here, unmultiply, and see what was the original problem before someone distributed. Well, greatest common factor means that it is something that will divide evenly. It's common in both terms. Greatest means I'm trying to get the most stuff to pull out of both terms. And of course, being a factor means it's something that is unmultiplying. So for instance, let me show you something that's not the greatest. Well, you know what divides evenly into both of these is a common factor of 1. I could pull the 1 out or factor a 1 out and say this is what it would look like. Well, that's worthless. I didn't do a whole lot. That's because this isn't the greatest. I want the greatest. And so how in the world can I find the greatest? Well, there's several ways to do this. Okay. One way is to do some scratch work out to the side and take your terms, and you'll see what's called greatest common factor here, and see if you can pull them apart. So what things multiply to give you 10? Well, there's 2 and 5. We also have this x. And if any of these break down further, besides 1 times something, I would like to keep going. Does 2 break down to, no, it's just 2 times 1. How about 5? No, that's just 5 times 1. And x, okay. So that's because these are prime pieces. What does 15 break down into? That breaks down into 3 times 5. Okay, none of those break down any further. Those are prime. Do they have anything in common? Well, yeah, they both have a 5 in common. Do you see that? That's what we're going to want to pull out or factor out. That must have been what was distributed, and what was left was a 2x in the first term and a 3 in the second term. So that's one way of thinking about it is, if you could factor everything, every little term down, you get the greatest amount of stuff that's common. Here only 5 is common, and you say that was what was distributed in. I would like to undistribute and pull it out. What's left in the first term? 2 and x. If I pull the 5 away, what's left in the last term? A 3. Another way of thinking about it is you say, okay, what's common here is a 5. All right, so I would like to put that 5 out front. Well, to figure out what's left in there, now you could do some scratch work and do this division that we just did. 10x divided by 5 is 2x, and 15 divided by 5 is 3. So you could think of this in either way. These are two different ways of conceptualizing doing factoring by pulling out a GCF. And this is directly related to the skill we just learned, so you may be more cozy with this. This makes a lot of sense too, so you may be more cozy with this. I don't care which way you do it. We're trying to go backwards here, okay? Let's do a few more examples, and then we'll call that a day. So let's look at one like this. Let's say I have 12x squared plus 20x. Okay? And I'd like to factor out the GCF. So let's do some scratch work. Let's at least find what the greatest common factor is. So 12x squared, and we have 20x. So let's see, what's in common here? Well, let's see, what can we break this down into? Well, first off, 12 I could break down into something like 2 times 6. And x squared, I could break that down into x times x. Okay? Am I done here? No, this 6 can break down further. So I can have 2 times, what does a 6 break down into? 2 times 3, and then bring down these times x and times x. So I have 2 times 2 times 3 times x times x. So I'm just thinking and tearing this apart. All right, what does the 20x break down into? That would be like, I could do 4 times 5, bring down this times x. Ooh, the 4 can break apart more. It can break into the 2 times 2 times 5 times x. So is there anything that these have in common? And the answer is yeah. I see 2 2's. They both have 2 2's and an x. They both have these pieces. Because I'm looking for the greatest common factor, I would like to get all of this, which would be 4x. And if I take that away, what's going to be left in the first term? What's left? A 3 and an x? And if I pull it out of this term, I've taken the x, I've taken the 2 2's, all I'm left with is a 5. Okay, so if I'm factoring out this 4x, I'm going to be left with 3x plus 5. What if you don't want to think about it this way, you just want to find the greatest common factor? Well, then you could do some scratch work with your long division. Not long division, simple division, dividing by 4x. And what would you get here? Let's see. So we'd have 12x squared divided by 4x. Well, that would be 3x. And you have 20x divided by 4x. That'd be plus 5. So you could do it either way. What's another way of finding the greatest common factor without having to do all of this work? This seems a bit tedious. Well, a lot of people are really good at just eyeballing it and asking the question, what's the biggest number that divides into 12x squared that also divides into 20x? And so people can look here and think, 2 does. Is there a bigger number? Yeah, 4 does. Is there a bigger number? Nope, that's the biggest number, the greatest number, that divides into 12 and into 20. Now, they both have x's. Since this one is x squared and this one's x, the most I can factor out is the smaller one, x. So I could factor out 4x. So some people do it just by looking and thinking. Some people take the time to expand everything out and find the common factors. If you do that, you might as well jump right to the answer by using these. Or if you think what's the biggest thing, then you might need to do some scratch work and see what happens when you divide it out to find what's left over in there. So there's several ways to do this. Let's do maybe 1 or 2 more examples. 2 more examples. Let's do something like, ooh, this is a good one. 3x minus 15. What's the biggest number? Let's do it this way. That divides evenly into both of these. And you look at it, and if I were to do that scratch work, I have 3x, and I have this 15, or minus 15. And this is just 3 and x. I could break down 3 into 1 times 3, but like I said, the 1s are kind of worthless here. And 15 is 3 times 5. So the only thing they have in common is a 3. So that must be what was distributed, and I'd like to undistribute. If I undistribute the 3, what's left? An x and a minus 5. Okay, that wasn't too bad. We should be getting quicker at these. Let me give you one more. Let's go with 16 x to the 5th minus 12 x to the 3rd. And we look at this. Let's see if we can do this without all that extra work. Is there a number that divides evenly into both of these? Yeah, they both get divided by 2. Is there a larger number? Oh yeah, 4 divides evenly into both of these. So 4. How about x's? This has 5 x's I could pull out. This has 3. I don't want to pull out more than anybody has, so I can pull out 4x to the 3rd. If you weren't sure about that, you could take the time to expand these all out, and you would end up with 2 times 2 times 2 times 2 and 5 x's. And the other one, 12x to the 3, you'd end up with 2 times 2 times 3 and 3 x's. And you say, okay, what's in common here? I see 2 2's is common in both, and 3 x's. Okay. And so then I need to do maybe some scratch work long division if I didn't do it this way to see what's left behind. So if I'm factoring out or pulling out this 4x to the 3rd, 16x to the 5th divided by 4x to the 3rd, that would be 4x squared minus 12x to the 3rd divided by 4x to the 3rd. That would be a 3. All right, so we kind of have a jump start on our factoring. Since we're good at dividing, it's not too hard to jump into factoring out greatest common factors. Now where we'll go next lesson is we'll actually dive into like a full factoring lesson, trying to see if we can factor trinomials into binomials, and we'll take some time on that. All right, I'll see you next time.